Hi, in this demonstration, I will show how our SEC cybersecurity solution VSP protects Microsoft SharePoint Server against the remote code execution vulnerability known as Toolshell, a combination of CVE-2025-53770 and 53771, which CISA has recently flagged as being actively exploited in the wild. What makes VSP unique is its ability to deliver true vulnerability mitigation with zero dwell time. This means with VSP, customers can expect to prevent exploitation of a vulnerability even if a patch has not yet been applied, even in the absence of a known IOC, even if the threat actor modifies or evolves their exploit, even if the patch is broken and needs another patch. In this case, Microsoft patched CVE-2025-43704 and 43706, which later then resulted in 53770 and 53771 respectively. Here are the details of the latest CVE. These are the vulnerable versions that are affected by the CVE. The Toolshell attack targets vulnerable versions of Microsoft SharePoint Server. For this demo, we use SharePoint 2016 version 16.0.4615.1000. The attack begins with exploitation of 53771, which results in authentication bypass, followed by 53770, which results in a remote code execution attack using PowerShell to drop a webshell. The threat actor then uses the webshell to extract sensitive machine keys used to protect serialized data saved in view state, an ASP.NET artifact used to pass state between post requests. The threat actor then uses the machine keys to drop an encrypted malicious serialized object containing the malicious payload. The malicious and encrypted payload passes through the web firewalls and explodes in the context of the SharePoint app. The CVE has a base score of 9.8, making it a critical vulnerability. Here we have the kill chain. In the initial stage of the attack kill chain, step 1 through 4, the threat actor exploits 53771 and 53770 to deliver a deserialization payload to an unauthenticated page, resulting in the execution of a PowerShell command. In step 5, this command dropped a webshell named spinstall.aspx into the server's webroot folder, though the webshell could have been named anything, rendering IOC-based detection solutions ineffective. In step 6, the threat actor sends a request to the webshell, which responds with exfiltrated machine key info from the server's web config file. This information is later utilized in step 10 to craft a malicious view state payload. In step 11, the attacker delivers this malicious payload to the vulnerable toolpin.aspx page, enabling remote code execution through unsafe deserialization. While the payload could perform any action that the threat actor chooses, such as deploying ransomware or leveraging lolbins, for this demonstration we will construct a PowerShell-based Metasploit backdoor. Once executed on the server, this payload grants the threat actor full remote access to the SharePoint server, effectively owning the workload and gaining the ability to execute arbitrary code. Vertex VSP protects the workload early in the kill chain, especially at step 4 in this case, by preventing the threat actor from executing the malicious PowerShell command to drop the webshell, thereby halting further propagation of the attack. Let us explore the attack with VSP running in detect and respond mode, where the response action is to simply post the threat into the SIM. In this mode, we will see all the steps the threat actor will carry out. VSP will log all the threat actor actions. The essence of true vulnerability mitigation cannot be achieved in detect and respond. A true vulnerability mitigation product prevents the vulnerability from being exploited with zero dwell time. To demonstrate this, we will later explore the attack in VSP's protect mode, where the threat actor is blocked early in the kill chain, resulting in zero dwell time and preventing any opportunity for exploitation. Let us get back to the detect and respond mode demo. Here we have the SharePoint application running at the respective domain on port 10188. This is the CMS dashboard. We can see here that VSP is deployed in detect and respond mode. On the left-hand side of the screen, we see the threat actor server, which I have hosted at the IP address 1047.7.205. On the right-hand side is the vulnerable SharePoint server I have hosted at IP address 1047.7.76. This is the web root folder where the threat actor will drop the malicious web shell using PowerShell. Now let us execute the exploit script by providing the base URL of the SharePoint application as input. Here we can see that the SharePoint server is a vulnerable version. Now it's trying to drop a web shell onto the server. The web shell drop is successful. Now it's using the web shell to dump the machine keys. We have successfully captured that info. Let us use the YSO serial tool to build the AVO state payload. I have already built it and stored in the response.txt file. Now it's executing the final payload to get the reverse shell of the machine. The PowerShell is executed successfully, and we can see in the MSF console terminal that we have got the reverse shell from the SharePoint server. Now on the threat actor's machine, let's use the shell feature in the MSF console to attempt opening a command prompt. As shown, we have successfully obtained a shell. Let's run a few commands to verify the connection. We can confirm that we have administrative access, and from the ipconfig output, it's evident that we have connected to the SharePoint server. Let us get back to the CMS. Here we can see that we have already received alerts for the attack. These are the ticket details. Here we can see the encoded PowerShell command used to drop the web shell. Here in the file integrity alert, we can see that we have detected a malicious web shell that was dropped. We also see the encoded PowerShell command that was used to get the reverse shell of the machine. Based on the ticket data, inspection of the SharePoint server reveals a malicious PowerShell process with an active TCP connection to the threat actor's command and control server. We also observe a suspicious file dropped into the web root directory. Upon analysis, it is identified as a web shell designed to read and exfiltrate machine key and relay them back to the attacker. Now let us rerun the attack, but VSP will be in protect mode this time. As explained earlier, this mode delivers the true mitigation solution where the vulnerability cannot be exploited. In this mode, the threat actor will have zero dwell time. Let me enable the protect mode for the SharePoint server. Let us also start the process monitoring. Let me execute the script. As you can see, the web shell drop failed. In the process monitor, you can see that we do not have any commands, meaning VSP has successfully blocked the attack. Now let us go back to the CMS dashboard. We can see an incident for the attack. The first incident, Vertex VSP successfully blocked the PowerShell command that was used to drop the web shell. By blocking the threat actor's ability to execute any code, VSP achieves true vulnerability mitigation. Thank you.